Hey folks, welcome back to another video. Today we're looking at question 423, reconstruct original digits from English. When you look at the problem, it seems very complicated. How would you go about figuring out how many letters there are? How can you fix them in such a way that each and every single digit comes together to form one digit word? And how can you do that with the rest of the letters? It's pretty complicated if you think about it that way. But if you think about it as the number, like the unique letters in each number word, it's easier to solve. So for example, let's start with 2, right? 2 is the only word that has a W in it. 3 does not have any unique letters, but it has H, and H is the least appearing digit. So for example, if you see T appears multiple times. It appears in 2, it appears in 3, it appears in 8. But if you take H, it only appears in 3 and in 8. So let's just highlight H for 3. And for 4, U was unique in all of the words, so you highlight that. In 5, you can take F because it only appears in 4 and 5. You could also take 7, I suppose. Sorry, B, I suppose. But let's just stick to F for now. And then 6, X is unique. 7, none of the letters here are unique except, S is the least times that's being used in all the words. So you use S as a special word, the special letter, and H is uniquely used in 8. Unfortunately for 9, you don't really have anything unique, but I is the one that appears least. So you just take I, and then you take, for 0, you just take Z because Z doesn't appear anywhere else, right? So once you have these calculations, what you do is that anytime you see a letter that we've highlighted here, you just increment that digit. So how exactly does that work? I would have typed out the entire solution, but it's just a very writing heavy solution, not so much based on logical problem solving. So what do we do here? We take the string that's given to us, convert that to a char array, and then we create a nums input integer array, and then we go through all of the letters, and anytime we see those letters that we have highlighted here, right, we just increment those. So for O, we know O appears uniquely only in 1, so you increment 1, and you do that for all of them. W for 2, H for 3, right? So you go through all of the letters and increment them. However, as soon as, because some of the digits that you see here, they have letters appearing that can appear in other words as well. So what you do is you try to subtract for them. So here you see that F, which appears in 5, also appears in 4. So what you want to do is that, because you know how many times 4 appears, and you can count that uniquely because only U is used in 4 and nothing else, you can subtract the number of 4s from 5s to get the number of 5 there actually are. So you can do that for 7 as well, because S appears in 6 and 7, but we know the number of times 6 appears because we're counting X, right? And you just subtract the number of times you've seen 6 from 7, and that's how you get the unique times that you actually get 7. And you do that for all of the numbers. You do that for 3 and 8 because you've taken H, 1 because you've taken O, and then 9 because you've taken I. And then after you have that, after you're done with this calculation, now you know how many times each number appears uniquely, and then you can just use a string builder. So how do you do that? You iterate through the entire nums area that's given to you, and anytime you see how many times you've seen that number, you actually need to continue adding that, right? So you just add that to a string builder and then convert that to a string and return it. So the problem itself, once you understand how to solve it, it's pretty simple, but it's just something that takes time to type it all out. Yeah, if you have any questions about this problem, please let me know in the comments below. Let's talk about the space and the time complexity. The time complexity of the entire solution is O of n, since you have to go through each and every single letter. The space complexity is O of 1, since we're not using a lot of space, but we're using constant space to solve the problem. Awesome. If you have any questions about the problem, please let me know in the comments below. Don't forget to like the video, subscribe to the channel, and leave any comments if you have any. It definitely motivates me to make more videos. Thanks so much, and I'll see you all in the next video. Peace.